all the story, but it's very important for you to look at this question here. We have the word elevation, angle of elevation, right? You did angles of elevation and depression in grade 10. If you forgot, you might need to refresh yourself with regard to that. But the angle of elevation, okay, it is an angle when a person is looking up, okay, and it's an angle between the horizontal plane and the line of sight. If you are looking at something which is up there, that is above the ground or above a horizontal surface, the angle between the horizontal plane and the line of sight is what's called the angle of elevation. Then the angle of depression now, it is between the horizontal plane and the line of sight when you are looking down at something. Like if I'm looking at the leg of a chair, the angle between the horizontal plane, that is my eyes, and that leg of the chair, that's the angle of depression. Okay? Both angles are acute angles. The angle of elevation and depression are acute angles. Sometimes the angles can be alternate. Okay? Angle of elevation and depression can also be alternate in some questions. Alright, so here we are told that the captain of the boat at sea at point Q, which is this point here. So the boat is on the surface of water, right? Notices a lighthouse, that is PM. This is PM here. So he was on the water, notices a lighthouse, that's PM, right? Directly north of this position, he determines that the angle of elevation of P, the top of the lighthouse from Q, is theta. So this is our angle of elevation is theta. And the height of the lighthouse is x meters, so the height of that lighthouse is x meters. From point Q, the captain sails 12x meters. So from point Q, okay, the captain sails 12x meters in a direction beta degrees, which is this angle here. That's beta degrees. So from point Q to point R, that's 12x meters. Alright? From point R, you notice that the angle of elevation of P is also theta. So the angle of elevation of P is also theta. So from point R to point P, the angle of elevation is that. That's theta as well. So we have got two thetas in this question. Right? Obviously, point Q, M, and R are in the horizontal plane, meaning they are on the surface. They are in water. Okay? I mean, that's what it is. Or you can say in this case, point M is going to be in the same horizontal plane as point Q and point R. Alright? So that's what the question says. Then, the first question says, write QM in terms of x and theta. Now, whenever you're answering a question of this nature here, always identify triangles first. Identify triangles, especially right-angled triangles first. The reason why you have to identify that right-angled triangles first is because you can easily use the Trig ratios from grade 10. Okay? You can easily use the Trig ratios from grade 10 if it's a right-angled triangle. Because most of these questions, they require the use of Trig ratio, that is sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, tan theta is opposite over adjacent. Alright? So, I've got two right-angled triangles, that is PQM and PMR. Those are the two right-angled triangles, which means I might need to use my Trig ratios, any of the three, in probably both of the two triangles. So here, I need to write QM in terms of x and theta. There is no other letter or any other number. Maybe my have probably a coefficient in the answer. So my QM is from here to there. That's QM. Okay? Now QM is part of triangle PQM. Fortunately, the length of PM is x and the angle of PQM is theta. I need to write QM. So with reference to angle theta, this becomes the opposite side. Obviously, that's your hypotenuse, and this side QM is going to be the adjacent side. Okay? Since we don't have the length of the hypotenuse yet, It means you can't use sine or cos. You have to use tan. Okay, I'm going to repeat that. We don't have the length for PQ, okay, but based on our reference angle of theta, PM is our opposite side from trig ratios, and QM is going to be the adjacent side. So we have to use tan here to do 7.1, which means 7.1 is a grade 10 question. It's not a grade 12 question. So 7.1, first I'll write here, tan theta is equal to, you can write the formula, that's all over A, that is opposite over adjacent. Okay? Then we substitute tan theta is equal to the opposite side, that's x, the adjacent side, that's qm. Remember, we are supposed to write qm in terms of x and theta, which means I need to make qm the subject. The denominator there is 1, so you just cross multiply this. So your qm is going to be equal to x over tan theta. You cross multiply this 1 and the x, you get the x. Okay? So this will be the answer for 7.1. Right. From my experience, most learners, when they see a question like this with a paragraph on top, then a diagram, the brain shuts down. But some of these questions are so easy if you just know your basics. So the concepts that I told you about, trig ratios, compound angles, double angle, reduction formula, area signing, cosine rule, sometimes theorem of calculus, and so on. You'll be able to answer these questions. Okay, so 7.1 is a grade 10 question. All right. It says prove that tan theta is equal to cos beta over 6. Okay, prove that tan theta is equal to cos beta over 6. Now, because we are introducing cos here, okay, and if you look at the angle, look at where cos beta is. It's part of a triangle that's not right angle. Which means, for me to have that cos, there are different scenarios. Maybe I might need to use compound angle, maybe double angle, maybe reduction, and so on. So you have to figure it out. Okay? The tan theta, usually, question 7.2 has a connection with 7.1. Okay? This tan theta here, that's the one that we got there. Okay? There is a connection. These questions have a connection. So this tan theta here, we already have it from that formula. And this QM here, it is part of two triangles. It's part of QMR, it is part of PQM. So I may need to incorporate that into my answer. Alright? So, if I want to prove that tan theta is got cos beta over x, so over 6 rather, it means I'm going to need to use triangle QMR for me to be able to do that. So for me to carry on, I now know that QM is equal to x over tan theta. Okay? And I know this is beta. In this case here, I want you also to be aware that MR, we can find MR in terms of tan theta as well. Okay? Because if I use trig ratio, this is the opposite side, that's the adjacent side. So what that means is, since this x here is it's common to both triangles, and this theta here is equivalent to that theta, I can find the length of MR in terms of theta. And that length is gonna be equal to x over x over tan theta. You agree with me on that?
Yes.
It's the same as the length of QM.
So that's the reason.
Okay? Well, no, don't have to give a reason here because this is trig. But the reason is that PMR is a right angle triangle. So our reference angle is theta, that's the opposite side, this will be the adjacent side. So if I want to calculate the length of, I'll say the length of MR, I'll say tan theta is equal to opposite over adjacent whereby my opposite side is x, my adjacent side is mr. So this will give me mr as x over tan theta. Okay? So the question now is, how am I going to create that cos theta? Okay? Now to create the cos theta, you may need to use the cosine rule. Okay? You may need to use the cosine rule here. Now if you use the cosine rule, right, it means you are trying to find the length of mr using this 12x, that theta, and that x divided by tan theta. Okay? But that same length.
I'm terribly sorry for this interruption. This is quite an internal call. I can contact the emergency please.
But that same, this same line mr here, the length in terms of x and theta is x over tan theta, but I can also get it using beta without using theta. Okay? That's one way. If you try to use the sine rule, okay, the sine rule, if you try to use the sine rule, unfortunately we don't know the size of this angle here. We cannot assume that it is 90 degrees. Also, we don't know the size of this angle. Okay? So the only way of incorporating cos beta is to introduce the cosine rule. It's not a right angle triangle, so you can't use trig ratios. It's not a right angle triangle, so you can't use trig ratios. So I'll say here the length of mr, okay, I can write that as mr squared is going to be equal to, I'm going to use the cosine rule. Okay, mr is going to be equal to qm squared plus qr squared minus 2 times qm times qr times cos beta. Okay? Now be aware that this mr squared, this mr squared, I can also write this x over tan theta all squared. Be aware of it. So let's simplify and see. So qm, that's the length there, that will be x over tan theta all squared plus qr, that's going to be equal to 12x all squared. Alright? Are you following there? That's qr equal to 12x squared minus 2 times qm, that's x over tan theta, times qr, that's 12x times cos beta. Okay? So all this is equal to mr squared. But the same mr squared is also equal to x over tan all squared if we use triangle PMR. Okay? So let me simplify the right hand side. Right? I'm going to move on to the next step. So here I'm going to square this, square that, and multiply all that and see where I'm going to get to. Are you following? If you've got any questions, feel free to answer, to ask rather. I'm going to repeat this. I'm using the cosine rule because it's not a right angle triangle. I can't use trig ratios there. So the only way that I can create that cos theta is by using the cosine rule. I can't use the sine rule. Okay? I can't use the area rule. Well, the area rule and the sine rule, they both have sine. The only one which has got cos is the cosine. Right? So let me, now here, for me to cancel out this x over tan theta all squared, for me to make sure that it disappears, I just have to write mr squared in terms of x over tan theta. Okay? So allow me to leave this as it is and let me simplify all the other parts. So I'm moving on to the next page. So my next page I'm going to say mr squared is equal to x squared over tan squared theta plus 144x squared minus, now if I simplify this, I'm going to simplify this part here. Now that's going to be from here, the 2 or the minus 2 multiplies the x, it multiplies the 12x. So I'll end up getting minus 24x squared. Remember, this 2 is like a whole number, the x is like a whole number, and the 12x is like a whole number. So I'll get minus 24x squared. Okay? So I'll get minus 24x squared over tan theta times cos beta. Right? If you do it step by step, you will see that it will be making sense and the answer will come out. So we need to eliminate this x squared over tan squared theta. The only way you can do that is to substitute x over tan theta all squared, because that's the value of mr that we got here. Okay, when I did the calculation here, remember what I got here. So I'm going to use that now. So when you simplify, right, this is the same as the x squared over tan squared theta plus, that's 144x squared minus 24x squared cos beta over tan theta. Okay, I can see my answer coming out. So these two are going to cancel out. These two will cancel out. They are like terms. You take either the one on the left to the other side or this one to the other side, they will cancel out. So if I cancel them out, I'll be left with a 0 on the left, and I'll have 144x squared minus 24x squared cosine of beta over tan theta. Then, to simplify this, I'll take the minus 24x squared times cos beta over tan to the left, and I'll get 24x squared times cosine of beta over tan theta, that's equal to 144x squared. Then, I'm sure you can agree with me that because we have monomials on both sides, this x squared and that x squared cancel. Then I need to divide, or we can say we can divide both sides by 24x squared. So once the x squared and x squared disappear, the next thing is for me to divide, or in actual fact, there are two ways of carrying on. I can divide both sides by 144, or I can divide both sides by 24. It's your choice, okay? So I'm going to divide by 24. If I divide this by 24, I'm going to get 24 cos beta over 24 tan theta is equal to 144 over 24. Right? Then let me carry on. So let me carry on here. So from here, I'm going to get cos beta over tan theta is going to be equal to 6. Then be aware that the denominator there is 1, then you cross multiply, you get cos beta equal to 6 tan theta. And if you switch those two, you end up getting tan theta equal to cos beta all over 6. And we'll do that.
So,
this one here. Okay. You see? Okay. Alright. If you have 24 cos beta over tan theta, if you divide it by 24 over 1, that would be the same as 24 cos beta over tan theta times 1 over 24. And this will give you cos beta. These two will cancel out anyway. Or you can write it as 24 cos beta over 24 tan beta. Okay. So the division that I did here, I just replaced the normal division line with the division sign. Then I introduce multiplication and swap the numerator and the denominator. Okay. Any question?
So can I ask, if you divide by 10 you don't divide by 10
Why would you do that? Because you know what the objective here. The objective is to isolate the cos beta and the tan beta.
Yes.
So that you can have.
Divide by 10
No, you don't have to divide by tan beta.
Yes.
You don't have to divide by tan beta. Okay? We need to eliminate the coefficient 24 on the left.
Yes.
Because our equation, remember, you need to remember to be aware of what are you trying to prove. We are trying to prove that tan beta is equal to cos beta over 6. So don't touch the cos beta, don't touch the tan beta. Okay? Since we have got a 24 here, we need to eliminate that 24. By the time you get to this point here, you must see that, okay, 24 is a factor of what? Of 144. You must see that. All right. Okay, next one. The next one says if beta is got 40 degrees and QM is 60 meters, calculate the height of the lighthouse to the nearest meter. Right? The height of the lighthouse is x, remember. Remember it's what? It's x. So already we had the formula from 7.1. So we know QM, but here we are also given beta, right? So for me to calculate QM, in this case I need to calculate x. So from this equation here, this one, I'm going to use this equation to calculate what? Tan theta. Right? Then once I get tan theta, I can be able to calculate x. I'm given QM. This question here, 7.3, everyone should be able to do it because it's now application of 7.2. Let's say you write an examination, you did 7.1, you can't do 7.2. At least you should be able to do 7.3. Because 7.3 is just using the formula that's given. Okay? So let's carry on now. Next page. So let's do 7.3. So 7.3, we are using tan theta equal to cos beta over 6. And we are told that beta is 40 degrees. So tan theta is going to be equal to cos 40 degrees over 6. Now, I'm not going to convert that cos 40 degrees over 6 to a decimal. Okay? I'm going back to my formula in 7.1. The one that I got is 7.1. QM equal to x over tan theta. Because I need to find, remember I need to find x. Don't forget that. So, my QM is equal to x over tan theta. But I want to find x, but my tan theta is equal to that. So I can write this as x equal to QM times tan theta. And then my x will be equal to QM. In this case, we are given the length of QM as 60 meters. So I have to substitute that 60 meters now. So this becomes 60 times that cos 40 degrees over 6. Right? Then let's go back to the question. Does it give us any restriction with regard to how the answer is supposed to look like? Right? It says to the nearest meter. So I need to convert whatever answer I'll get. So what answer would you get? Obviously you're going to get 10 cos 40 degrees. What is 10 cos 40? Can you give me the answer with the decimal space, 2 decimal places? 7,66 meters. Therefore, x will be equal to 8 meters. You have to write down this first. The answer is a decimal. Then you convert to the nearest meter after that. All right. So this is how you can answer some of the question on 2D and 3D.